Hello everyone. In this video, we shall discuss how to solve for radical equations. Now, some radical equations would actually lead to quadratic equations, but whenever solving for radical equations, we always check if the obtained value of x would actually satisfy the given equation. So first, in our example here, this equation contains a single radical. So whenever the equation has a single radical, then we have to separate it. We have to put it in one side of the equation, and then the rest of the terms should be at the other side of the equation. And then we're going to square both sides. So if we square root of 3x plus 1, quantity square will just be 3x plus 1. And then we're going to square x minus 1. So the square of x minus 1 is the square of a binomial. So it should be x squared minus 2x plus 1. And then we transpose everything on the right side to the left side. So we get negative x squared. Then this negative 2x will become positive 2x and will be added to positive 3x. So that gives us positive 5x. And then the positive 1 here will be or will become negative 1 to the left side. So it's 1. And then minus 1 here. That's going to be 0. And then the right side will now become 0. So here, we can factor out x, and then we get negative x plus 5. So both of these factors can be equated to 0 by the zero product property. So we get x equals 0. And then for the other one, we get negative x plus 5 equals 0. So transposing positive 5, we get negative 5 at the right side. And then dividing both sides by negative 1, we get x is equal to positive 5. Now, again, as I said earlier, that once you obtain the values of x, then we need to check whether those values will satisfy in the given equation. So when x is equal to 0, then we get the square root of 3 times 0 plus 1 is equal to 0 minus 1. So let's put a question mark here. And then the square root of 3 times 0 plus 1, that's the square root of 1. And then 0 minus 1 is negative 1. However, square root of 1 is positive 1. And then the right side here is negative 1. So this tells us that x equals 0 is not a solution to this equation because what we got here is not an equality. And then for the second value, x equals 5, we get 3 times 5 plus 1 is equal to 5 minus 1. So for the left side, that's going to be 15 plus 1, which is 16. And the square root of 16 is 4. And then we have 5 minus 1 in the right side, which is also equal to 4. So here, this indicates that x equals 5 is a solution to our equation. So only x equals 5 is the solution. Next, for example number 2, let's have the square root of 3x plus 12 minus 1 is equal to the square root of 5x plus 9. So since this equation contains two radicals, then we have to make sure that one radical sign must be on the left side and the other is on the right side. And then we're going to square both sides of the equation. So if we square the left side, it's going to be the square of a binomial. So to square this, we will be squaring square root of 3x plus 12, and that's going to be just simply 3x plus 12. And then that's minus twice the product of this term and this term. So that's going to be 2 times the square root of 3x plus 12. And then we're going to square negative 1, which is positive 1. Now for the right side, the square of this radical is simply 5x plus 9. And then we're going to transpose the radical on the left side going to the right side, and then everything on the right side will be transposed to the left side. So this will become 3x plus 12, and then there's a plus 1 here, and then the 5x will become minus 5x, and then the 9 will become minus 9. While this one, the negative 2 times square root of 3x plus 12 will become positive 2 times the square root of 3x plus 12. Combining like terms on the left side, we get 3x times negative 5, and 3x minus 5x is negative 2x. And then we have 12 plus 1, which is 13. 13 minus 9 is positive 4, equals 2 times the square root of 3x plus 12. Now, at this point, we see that we have negative 2, positive 4, and positive 2 as the coefficient. So we can actually divide both sides by positive 2. So we get negative x plus 2 is equal to simply the square root of 3x plus 12. So now observe that our equation is now an equation involving only a single radical. So which means to solve this equation, we shall square both sides. So squaring this, we get x squared, and then minus twice the product of the following. So the product is 4x. So x squared minus 4x, and then the square of positive 2 is positive 4. And then squaring the square root of 3x plus 12 will be 3x plus 12. And then transposing everything here on the right side, going to the left side, we're getting x squared minus 7x. And then 4 minus 12 is negative 8 equals 0. So now this is a quadratic equation in standard form. So we can use factoring to solve this equation. The factors would be x minus 8 and x plus 1. So using the zero product property and solving for x, we get x equals positive 8 and x is equal to negative 1. So again, since this is a radical equation, we need to check if x equals 8 will satisfy the following. So that will be the square root of 3 times 8 minus 12 plus 12 minus 1 equals the square root of 5 times 8 plus 9. So let's put a question mark here. So 3 times 8 is 24. 24 plus 12 is 36. And then the square root of 36 is 6. And then there's a minus 1. So that's gonna be 5. And then for the right side, we have 5 times 8, which is 40. 40 plus 9 is 49. And then the square root of 49 is 7. So 5 and 7 are not equal. So that means x equals 8 is not a solution to this radical equation. And then for the second one, for x equals negative 1, we will be substituting it. So 3 times negative 1 plus 12 minus 1 equals the square root of 5 times negative 1 plus 9. So 3 times negative 1 is negative 3. Negative 3 plus 12 is 9. Square root of 9 is 3. And then there's a minus 1, so we get 2. And then at the right side, 5 times negative 1 is negative 5. Plus 9 is positive 4. And the square root of 4 is 2. So this tells us that x equals negative 1 is a solution. And in fact, it's the only solution to this radical equation. So this ends the video about equations involving radicals. So I hope that you learned how to solve it, and thank you for listening, and I hope that you can subscribe to my YouTube channel. Thank you.